A citizens' organization called Arrest is trying to make more Canadian taxpayers aware that our federal, provincial, and municipal governments have decided to spend close to $1 billion of our tax dollars on a large infrastructure project that may not be environmentally and/or fiscally justified. It was a political decision that has very weak scientific and technical support, but is being supported by PR spin, political posturing, and inadequate media scrutiny. Extensive scientific research suggests that there are much more prudent ways to spend the funds, yet the political bureaucracy plows on with the project. So far, $22 million of our tax dollars have been spent toward the project, and there is still no plan for a cost-benefit analysis to determine if the project is even justified. The intent of this 22-minute video is to promote open and honest discussion of the issue based on science, facts, and evidence. The video is intended primarily for the citizens of the CRD, the Capital Regional District of Victoria, also known as the City of Gardens. But all Canadians are encouraged to view the video because the issue could potentially have national ramifications. The issue is about sewage disposal. Yeah, not something we like to talk about, but it is a social issue that we ought to be adequately informed about to be sure that it is dealt with by our representatives in an environmentally and fiscally responsible manner. Some people, including some politicians and bureaucrats, believe that discharge of any sewage effluent into the ocean is an outdated practice that simply must stop, whereas numerous studies have concluded that there are instances where the practice is justifiable. Arrest consulted with 3 marine scientists and a former public health officer to ensure that the following scientific and health facts and evidence regarding the issue are accurately presented. Victoria disposes of its effluent into the ocean through a wastewater discharge system that is specifically designed to utilize the natural treatment capability of the local marine environment. It is a disposal practice that the CRD has monitored for decades and has accumulated thousands of pages of data and hundreds of reports in one of the most intensive and thorough outfall monitoring programs in the world. This is well documented in reports freely available on the CRD's website. Dozens of study of the data and reports have been done by a multitude of professionals, including public health officers, wastewater engineers, CRD staff, and scientists at the Institute of Ocean Sciences, the University of Victoria, private consulting firms, and in Washington State. Marine scientists have gone on record stating that they do not see any urgent need for land-based treatment, and that the CRD's current sewage disposal practice is a relatively minor issue. They have further stated that if marine environmental protection is the goal, then much greater benefits could be achieved through a variety of other innovative actions. Past and present public health officers have also gone on record stating that there is no measurable public health risk from Victoria's current method of offshore liquid waste disposal, and that it does not make sense to plan a massive public expenditure for which no measurable benefit has been identified. Here is a description of how Victoria's current system works, and about how it interacts with the local marine environment. Let's start with 2 basic facts of life on this planet. All living things, including we humans, produce wastes, and all life exists in cycles. That is, each organism, its waste and its dead body, is organic matter that is food for other organisms. When properly distributed, that organic matter is not detrimental to the ecosystem, but is assimilated and nourishes the ecosystem's life cycles. The rate of assimilation is dependent upon such factors as the availability of oxygen and microorganisms in that ecosystem. Victoria's system discharges effluent into the Strait of Juan de Fuca, which is part of a larger body of water called the Salish Sea. Deep Pacific Ocean water that flows into the Salish Sea, symbolized by the yellow arrow, flows mostly along the bottom of the Juan de Fuca Strait. The light green arrows symbolize the massive amount of fresh water flowing into the Salish Sea from several major rivers, including the Fraser River, which make the entire Salish Sea region in effect a large estuary. The fresh water stays on the surface of the estuary as it continually flows toward the Pacific Ocean, symbolized by the blue arrow, but gradually mixes vertically with the salt water and becomes saltier as it travels. The inflow and outflow, referred to as estuarine circulation, continually replenishes the water in the strait and, combined with the Salish Sea's strong tidal activity, keeps the water in the strait well mixed and oxygenated. The volume of the circulation plays an important role, but is immense and hard to visualize. Perhaps it will help if you think in terms of the large tankers that ply the strait, which have capacities of over 100,000 cubic meters. The volume of the inflow of the deep Pacific water along the bottom half of the Juan de Fuca Strait is equivalent to one of those large tankers per second. The outflow on the top half of the strait is the same volume plus the river water, equivalent in total to slightly more than one tanker per second. Victoria's system discharges at a rate of about 1/100,000th of one of these tankers, a little more than a cubic meter per second. And the effluent is almost all water, 99.97% water. That's right, the effluent consists of only a small amount of organic and inorganic matter suspended and dissolved in a large amount of water. Before the effluent is discharged, though, it must pass through screens with openings that are only 6 millimeters, 1/4 inch, which is why it is physically impossible for the discharge to contain any large particles. All the screened debris and grease and oils that are removed from the effluent are trucked to Heartland landfill. After that preliminary treatment, the effluent is then pumped into pipes that extend from Macaulay and Clover Points for more than a kilometer along the seafloor into the Strait of Juan de Fuca. The pipes discharge into the outflow portion of the estuarine circulation through about 65 diffuser ports near the ends of the pipes, at a depth of at least 60 meters. The oceanographer Dr. Littlepage has viewed operation of the outfall diffusers from a submersible. He reports that, just a few meters above the diffusers, the slightly milky-colored effluent is no longer visible. This is dramatic evidence that the effluent disperses very rapidly, so rapidly in fact that by 100 meters from the pipes, the regulation distance for dilution measurements, it is 20 to 25 times more dilute than BC's own standard for wastewater treatment systems. It then continues to rapidly disperse to the natural background level of organic matter that is always suspended in seawater. The overall combination of circulation, mixing, oxygenation, dilution, and the ocean's microbes is very effective at dissolving and assimilating the effluent into the food chain of the Strait and the Northeast Pacific. This natural action is analogous to the aeration of effluent in land-based secondary treatment systems. A significant difference in the analogy, however, is that land-based aeration requires input of large amounts of energy, whereas this natural action utilizes the renewable energy of the tides and estuarine circulation. Victoria's system has so little effect on the marine environment that local waters and the Marine Ecological Reserve at Race Rocks, 15 kilometers downstream from Victoria's outfalls, are regularly referred to as pristine. One such occasion was when Prime Minister Stephen Harper and former Federal Natural Resources Minister Gary Lunn visited Race Rocks just 4 years ago, and local media reported that they marveled at the pristine environment. Even Macaulay Point itself is used for field trips to study the local natural marine environment. The accusation that Victoria dumps raw, untreated sewage into the ocean is inaccurate and misleading. It is just headline-grabbing PR spin aimed at trying to embarrass the citizens of Victoria. Speaking of inaccuracy, here is a photograph of one of the outfall pipes. There are several copper rockfish next to the pipeline. There are also noodle-shaped sea pens, sea stars, anemones, scallops, and mussels present. In fact, there is a myriad of thriving sea creatures both in the seawater and in and on the sea floor. Clearly, the accusation that Victoria's current practice has caused dead zones around the outfall pipes is utterly false. Out of view in the sediments are capitalid worms and copepods, which are always associated with high concentration of particulate organic matter. They are the biological equivalent of the digester ponds of a sewage treatment complex. The natural system around the outfalls would not function without them, in the same way that Victoria's garden composters would not function without earthworms. Charles Darwin spent years of his life documenting that worms are essential to the health of an ecosystem. This bar graph is packed with information about marine life near the discharges. life that is more abundant because of increased food near the discharges. The left side of the graph is nearest the discharge, and the height of each bar represents the amount of marine life present at a particular distance from a discharge. We can immediately see that the total marine life is greatest nearest the discharges and diminishes with distance from the discharges. The length of each color in a vertical bar represents the amount of a particular animal group present at that distance. This graph indicates a very important feature of this outfall ecosystem, which is that no one animal group dominates. It also shows a diversity of groups, which is indicative of a healthy ecosystem. Now let's review the current system's imperfections. A few times each year, bacteria may be detected at the surface above the outfalls, but for only a short period when a winter low tide coincides with a surge of fresh water into the system during a heavy rainfall. The only persons who might come into contact with these surface bacteria are windsurfers, but the concentration of bacteria is so low that the potential risk to health is minuscule. If that risk is a concern, it would make more sense to simply close the area during times of risk, just like temporary closures of beaches for similar reasons. Or the problem could be reduced or eliminated by spending only a few $1,000,000 to extend the outfall pipe and add more diffusers, rather than replacing the entire system for almost $1 billion. Another imperfection of the current system is that it does not remove some chemicals such as fire retardants. Other materials in the marine environment, such as tire rubber and petroleum products, are primarily from land runoff and storm drains. These are chemicals of concern, but once they are in the effluent or the runoff, it is very difficult or impossible for any treatment system to remove them because of their extremely low concentrations of parts per million, billion, or trillion. The most effective way to manage some of these materials is to ban them, as PCB was, and fire retardants will be. The next most effective way to manage them is to try to prevent them from being put into the system at all, a procedure called source control. Victoria already has an effective source control program in place to reduce the quantity of such chemicals entering the environment, and the program is continually being improved and expanded. Source control of many pharmaceuticals and personal care products would be difficult. However, they are extremely dilute, they slowly degrade in the marine environment, and studies have found that they are not causing any adverse effects.
So, there it is, Victoria's low-tech system that utilizes the ocean's energy and composting capability for efficient natural treatment with no measurable risk to human health and minor reducible effect on the marine environment. Yet the bureaucrats insist on spending almost $1 billion of our tax dollars to make us dependent on a complex biomechanical treatment system. But it is no panacea, and the plans for it have some serious flaws.
The plans call for a treatment plant to be placed at the entrance to Victoria Harbor, in full view on McLaughlin Point, directly across from the cruise ship terminal. A location on Victoria Harbor exacerbates any equipment failures, such as occurred in Halifax Harbor, and will likely depress property values. Compare such a future skyline with the current skyline at Clover Point, where our current pump house is tucked unobtrusively underground. The proposed system includes laying two 18-kilometer-long pipelines to transfer the sludge produced by the plant to Heartland Landfill, where it will be further treated and the excess water will be pumped back to Victoria for discharge into the ocean through a new outfall. The planned project will consume large amounts of energy to construct, tons of greenhouse gases will be created by the production of all the concrete needed and by the transportation of all the construction materials. Once completed, the system will be complex, technology-intensive, and energy-intensive. Large amounts of energy will be required for digester aeration and biosolids dryers. The plant's carbon footprint will continue to grow. After all the expense and disruption, this new system will not remove all of the chemicals of concern. Some chemicals are expected to be eliminated, but some will just be reduced or degraded. Others will be transferred to the land, and some are expected to continue to enter the ocean. Those that are removed will end up concentrated in the sludge. and there is still no clear plan for final treatment and disposal of the sludge. One proposal is to use it as a fuel to heat kilns used for the manufacture of cement, but that is misleading given that real fuel will actually have to be added to make it burn. Another proposal is to simply incinerate it. In either case, incineration will create airborne pollutants. It is currently estimated that the construction phase will cost $780 million, that the annual maintenance and operating costs will be $14 million, and that the cost to the average CRD household will be somewhere in the range of $200 to $500 per year. With regard to estimations, the 2009 study titled Delusion and Deception in Large Infrastructure Projects warns that cost overruns of 50% are common for large infrastructure projects. That certainly is our experience in British Columbia. The study also warns that such projects often finish with significant time delays and benefit shortfalls. So, what justifications have been put forth for such a project? A major one given is that a provincial minister of the environment directed the CRD to make provision for sewage treatment. However, one of the reports that the minister cited for his decision was the MacDonald report, but that report was never vetted by peer review. The other report he cited for his decision was the CTAC report, which is an internally contradictory, unfocused report that is entirely inconclusive as to whether or not Victoria should implement secondary sewage treatment. The CTAC report's conclusions offer no firm decision, but vacillate around the suggestion that the issue should be decided by a referendum on the matter after Victorians are made aware of the results of a state-of-the-art cost-benefits analysis. It should be noted that the minister's directive did not specify a land-based secondary treatment system, but that is what is being planned. Another justification given is that Victoria's discharges are supposedly contaminating the seafloor off Victoria's waterfront. But let's look more closely at the history of local practices. The CRD used to load the city's trash, including the likes of batteries, fluorescent light fixtures, lead paints, etc., onto barges by the Johnson Street Bridge and dump the trash just off the Victoria waterfront. That practice stopped in 1958, and our situation now is that the seafloor is contaminated in spots. Victoria now has source control programs to reduce contaminants, and the programs are constantly being upgraded. Past and present levels of contamination have minor effects, and the level of contamination is diminishing while the local population is increasing. Yet another justification has been the claim that the CRD's projected population growth makes the current system unsustainable. Such a claim depends on knowing the Juan de Fuca Strait's full capacity to assimilate. No study has been done to determine if current practice is anywhere near such a limit. One more justification given is that Victoria is going to have to implement a land-based treatment system anyway, because the Canadian federal government may impose national wastewater treatment regulations. However, the intent of those federal regulations is to impose a single standard of treatment on all of Canada, a mistake that the United States government made years ago. The U.S. learned that it is inappropriate to apply a single standard of treatment to the variety of receiving environments that exist throughout the entire United States. That U.S. regulation has been challenged and defeated in U.S. courts. The U.S. Congress commissioned the National Research Council, NRC, to identify opportunities to improve the single standard system of wastewater management in coastal environments and estuaries. Two of the study's recommendations are that coastal wastewater and stormwater management strategies should be tailored to the particular receiving environment, and that source control of pollutants should be strongly encouraged by incentives and regulation. Victoria's treatment system was already in accordance with those recommendations before the NRC even started its study. Each of these justifications for proceeding with the plan to replace Victoria's existing system is seriously flawed. Consider also that if it really is true that Victoria's current system is a problem, how is it that Victoria frequently ranks high in surveys regarding livability and quality of life? As an example, just this past February, the Corporate Knights magazine conferred upon Victoria 2 awards for 2011, Most Sustainable Small City in Canada and Most Sustainable City Overall in Canada. Citizens should be outraged that Victoria's sewage circus is being driven more by the antics of some clown dressed as a turd than by experts on the subject whose conclusions are backed by years of reports and reviews that our tax dollars have paid for. Out of respect for the natural environment, Arrest is calling for a full cost-benefit analysis to compare the proposed project with the existing system. Also, Arrest advocates for further enhancement of Victoria's continually improving source control programs. They generate the biggest bang for the ecological buck. Polls consistently show that 2/3 of Victorians oppose the project, but just opposition is not enough. Citizens need to contact municipal, provincial, and federal political representatives and the local media and tell them emphatically that the proposed project should be stopped. Exercise your democratic right to be an engaged citizen. If you have found this video helpful to understand the issue, please pass it on to fellow taxpayers. Arrest thanks you for taking the time to become better informed about this important issue. In closing, here is a list of marine scientists and health officers whose professional opinions have been included in this video.